Thanks for joining. Today we have day number 6, and today our agenda, our topics that I'm going to cover is that first of all, we'll go and check the OMP theory. So I have some slides, presentation slides, where we'll get some more detail about OMP and T-lock. And then next up, going to start the SD-WAN policy theory. And if time permits, then I will show you one example as well. So let's see this OMP. Actually, we have studied that in our previous session. What is OMP? How it is? What is OMP route, service route, transport route? So for that, if you go to this particular link, this is our topology that we have drawn earlier to understand that OMP having different type of routes. So you will understand now. Like BGP, OMP also having best path selection criteria, and it's very much similar to BGP, that first of all it will go so first of all it will go and check that OMP route having valid next hop or not. If it is not, then it will ignore it. Then it will go and check the route with lower AD value. So whichever route having lower AD value, that will get preferred. Then it will go and check the OMP route preference. There are two type of preference. One is OMP route preference, one is T-lock preference. So we can go and set the preference as per the higher OMP route preference first, and then as per higher T-lock preference second. It will go and select the best path. Then suppose if point number 1 to 4 they are equal, same, then it will go and check the origin type. Means the routes that we are getting is connected, static, eBGP, OSPF, etc. According to that, it will go and choose that best path. Means it will go and install that route as a best path route. Finally, it will go and check the OMP route with higher router ID. If all these parameters will be same, then VSmart will go and mark this that they are equal routes with equal T-lock, equal attributes, and then the edge devices will go and install this as a multiple active path in their routing table. So very easy, straightforward, uh, like we have in BGP attributes for path selection. Here we have the same. Now, generally what we are doing in production, that we are either using OMP preference or T-lock preference to prefer one path to other. That example we will see that once we learn that centralized policy or policy section. So there we have option that with the policy, we can go and put the OMP preferences. Even we have option to put the tagging as well, OMP tag. So those are very interesting thing that we will see. One lab I will show you later on in our lab section. Then what is graceful restart in OMP? Now these are the informative slides that is there for your reference. I will quickly go through for 1 or 2 minutes. Graceful restart means think like this, that due to any reason, if you have two control plane, two VSmart, and they will get rebooted or they will become unreachable from the edge devices, then what will happen? That means you have the data plane, but you don't have the control plane. So in that case, what is happening? Because since data plane work is this, that as per last known configuration from the control plane, they will work, they will forward the traffic. But what will happen if your control plane will become active? Means after some times, now your control plane is up and running. So what will be the state of the data plane devices? So in that case, the VSmart, they will send some sort of EO. So you will see there, I have listed here. So they will go and send EOR packet, end of RIB. That means VSmart will tell edge devices, okay, you are doing good earlier. Now I am back. I am sending you end of RIB, means I am sending you new routing information update, that whatever old entries you have, you flush those old entries and install the new entry, and you can work with the new entries. So that's why we have that technology called graceful restart for OMP. The timer is there. You can see here in the bottom, the timer is there. That timer is by default, it is, I think, 12 hours. We will see that if we go to OMP and if we type command timers graceful restart, let's see. We go here and show you that. So if I go to the SD-WAN lab, maybe this one, and VSmart. If you go to OMP timers graceful restart, you can see by default this is 43200 seconds. That means this is by default, this is 12 hours that we can extend up to 7 days, right? So after 12 hours, by default it is 12 hours, that after every 12 hours it is sending the new database to the devices, right? Apart from that, we study this thing in our previous section, and also we have the lab as well, that suppose you have VSmart and suppose you have your edge devices. Now we know that within the VSmart and the edge devices, we have the OMP. So in between the controller, we have OMP, and so very important that OMP is there, although OMP is there, but the gateway, that the interface within VPN 0, they are part of, means they are referring as a TLOC. TLOC, they are nothing but the next hop for OMP routes. So point here is this, that you don't have IP or advertisement only over this interface. What about the interfaces that you have in your LAN site? So suppose I have different VRF. So VRF red and VRF, for example, green. Let me go and change the color. So I have VRF red and I have VRF green. Think like this. Now these routes, suppose in this area, I am running some OSPF. Some OSPF or EIGRP is running. So point here is this, that this OSPF route, if we have some other branch or data center, suppose I have one other location, and in that location, I have to send these routes, these OSPF routes. And in other location, if we are running, for example, if we have EIGRP, then how EIGRP will reach OSPF? OSPF will reach EIGRP. So suppose here I have EIGRP running, because anyways, in between your edge devices and your VSmart, you have OMP, right? So point here is this, that the OSPF, VSmart, they have to go and redistribute. So it should, oops, the traffic should get redistributed, right? So this should be get redistributed here. It will reach to VSmart, and VSmart will send this traffic to service side VPN. Vice versa, the traffic should get redistributed from here. So from EIGRP to OMP, and again from OMP to OMP, and then OMP to OSPF. Like that, this complete redistribution process will happen. But now, if we think that this device, this router that we have here, if we think this router as a device which is running multi-protocol For example, OMP, OSPF. So it's actually very easy. Anything that you can go to OMP and you can advertise. So redistribution keyword in OMP is advertise. But OSPF, we know from our Cisco knowledge that within OSPF you have to redistribute OMP. Within OMP you have to advertise the OSPF. Like that you have to do. So the redistribution part here is actually easy. You can see that we can go to OMP, advertise BGP connected OSPF. We can go to VPN OMP, and then also we can advertise. It's easy and straightforward. Likewise, you can go to OSPF and you can advertise in the other direction. Then all the protocols, they have their timers. Yes, OMP also have their hold down timers of 60 seconds and tolerance timers as well that you can go and set. Advertise timer, end of RIP timer. So some timers are there and some distribution commands are there that you can go and have a look. This is just for your reference. Later on, obviously, we have certain labs related to local policy. Within local policy section, you will see little bit more about redistribution. One thing is very important while understanding these local policies or redistribution at least. The important factor is this, and that we will consider later on in the section, that suppose that you have VSmart and edge device. Now think like this, OMP will be very big database. You don't want to redistribute all the routes that you have in OMP to OSPF. If you do that, then it is something like you are redistributing BGP table within IGP. That is not a good practice. So that's why when we are redistributing OMP routes to OSPF, or maybe when we are calling OMP within OSPF, in other words, at that time we are putting route map. At that time we are putting route filters. We don't want all the routes from OMP coming to IGP. So that lab we will do later on in the policy section. Now let's continue this study and let's move to part number 2 that is very important, interesting, and that is SD-WAN policy. So let's understand this SD-WAN policy. And this SD-WAN policy is actually the core we have, the SD-WAN technology. SD-WAN policy. What is SD-WAN policy? How it is? We'll understand everything. So when we'll go and divide the policy, you'll find that from top, the policy having two parts. So for example, I have SD-WAN policy and suppose this is the SD-WAN policy. So suppose this is the policy, and this policy will be divided into two parts. So this policy may be control policy, it may be data policy. So control policy and data policy. Now, this control, whenever we have control, think control as simply as a routing. Control policy means routing policy. Data policy, now data policy is very interesting. It is something very much specific to that device. So if it is a data policy that is specific to that particular device, that particular router, we'll understand more about this. Now, either it's a control policy or it's a data policy. It has two legs. So in both the cases, you have centralize and you have localize. What does it mean by centralized? What does it mean by localized? I'll explain you. But either it's a control policy, data policy, you have the centralized policy, you have the localized policy in both the cases. So let's see the flow. We have like this, and we have like this, and then so that means that if you read any of the policy, you will find that, okay, I may have centralized control policy. You will read like this, centralized control policy, right? Or you may go and read like this, that you have, for example, localized data policy, or you may have centralized data policy, or you may have localized control policy or routing policy, right? So that will be the flow, actually, flow of the policy. Like you have, now you can see that you have 4 different type of policy, 2 within data policy, 2 within control policy, right? Now it's interesting. I already told you that control is nothing but routing policy. Now central policy and local policy means what exactly? Centralized policy means what? Localized policy means what? How it will be? So if we go and log into the vManage dashboard, there is one policy section. In that itself, we will see 2 tabs. You will see centralized policy tab, localized policy tab in the vManage dashboard itself. Okay, we'll check that later on. But point here is this, that centralized policy, as name suggests, right? Central policy. Central policy means who will create that policy. So as name suggests, that these centralized policies that we have, these policies that we have, this centralized policy that we have, it should be created with help of VSmart, right? That means we know that flow. Earlier, actually, we have discussed that flow earlier, that the policy is something like you can create at the level of vManage, then you will push to the VSmart, and from VSmart, you can go and push to different VS devices. So that means that within the vManage, you will create that VSmart, you will put that, and from VSmart, it will go to the S devices. Suppose VH1, VH or CH or CH3, like that. So point here is this, that oops, here from vManage, and then you will go and push. It's very important to understand here that vManage is using netconf, and from VSmart, you have the OMP session, you have the OMP that you are pushing the policy to the devices. This will be the flow. Now, when we are talking about this centralized policy, that means that centralized policy will be always part of VSmart, right? Who will create this centralized policy? Obviously, from vManage, it will get created to VSmart, right? So let me go and right, or maybe like this, I can centralized policy created by VS. Okay, and then it will push to the devices. Now, what about localized policy? Localized data policy will be what are the examples? So you will see that examples will be QS and ACLs and maybe port mirroring like that. Centralized policy, I will explain you about this, that centralized policy examples will be, centralized data policy examples will be data policy itself, data policy, it's a data policy. Apart from that, app route policy, CF load policy, service chaining, etc., etc. There are long list of the policies that we have part of the centralized data policy that you are creating from the VSmart pushing to the devices. Then centralized control policy. So control name itself is control policy. Here also you can do traffic engineering, route preference, route leak. You know, good examples are there. Even service chaining. Good examples of centralized policies are there that with the routing you can go and with the routing policy you can go and create. Apart from that, localized policy, as I told you earlier, that if anything belonging to control means routing, so the localized control policy will be route map or route policy. Anything that you are playing around with the routing, that will fall under localized control policy, localized routing policy, centralized routing policy, right? So this is actually a very interesting flow. Within the same small diagram, you can see that so many things are there, right? So many things are there. Now let's continue this understanding of policy, and let's understand little bit more about this centralized policy and the centralized localized control policy, centralized localized data policy. So let's understand this little bit more. So suppose let's divide this into two parts. Part one, we will go and check the control policy, and part two, we will go and check the data policy. So suppose that this is the control policy, and then suppose the other portion we have the data policy. Let's try to understand the difference in between these policies. So this is my control policy, and suppose this is my data policy. The difference between the control policy and the data policy, how we can go and check that. Now control policy, as name suggests, now, and again we are talking about the centralized control policy, centralized data policy, because local policy, again you have different tab. So point here is this, that when we are talking about these policies, right, let's take 1, 2, 3. So difference number 1, difference number 2, and difference number 3. So first will be that from where you are pushing. So from vManage to vSmart. So let's focus on vSmart. I am pushing this policy from vSmart, right? From vSmart to where you are pushing this policy? To the edge devices. Now that means that your C, A, and E, these are three terms. C means configure, A means apply, and E means here execution. So if CAE will happen at the rate of vSmart, that will be control policy. So you'll configure apply and execute at the level of vSmart. That will be your control policy, right? And then, very interesting, if C and A will happen at the level of vSmart, but the actual execution, but E will happen at the level of edge device, at the level of edge. That will be data policy. You got the difference number one. Difference number one is, it's very interesting. Everything when you are managing from one location, from the vSmart itself, that will be the control policy, right? Centralized control policy. But if you are doing the configuration and the apply with respect to vSmart, but the execution is happening at the level of the edge device. So that will be your data policy, right? Now, interestingly, if we have such type of scenario, that means from here we have point number two. So what is point number two? That, so that means clearly that the vSmart will be the owner of the policy. That means, what does it mean? So that means vSmart with OMP will send the policy updates to the devices. These devices do not download this copy of the policy. So that means that policy that we are creating, applying and executing from the vSmart, that will not be downloaded by the devices. And in this case, what will happen in the data policy, that vSmart will be the owner of policy. That's okay. That means vSmart with OMP will send the policy update to the devices. That is also okay. But these devices do download this copy of the policy. That means if you go to the edge device and if you go and check that command, show policy from vSmart, you will see this over vEdge or cEdge over the edge devices. So in short, that these edge devices will go and download the copy of the policy. They will download. Policy will be downloaded via the, if it is a data policy, it will be downloaded. It will be downloaded via the devices. Downloaded. Sorry for that. Let me correct that. Okay, so that is the difference number two that we have. And obviously in the lab, I will show you all these differences. Then what is the third difference? Third difference is also very interesting. Third major difference that we have is also very, very interesting. What is happening in that case? That since you have the control policy, right? So your control policy is actually quite interesting point we have about the direction. Control policy or policies are unidirectional. So what does it mean? It means that if you have Suppose I have one V Smart here and I have V Edge here. So it means that from in to out and out to in. So if you have certain things to do and you want to create the policy, you have to go and create. Actually, you can create the policy once, but you have to apply it twice. So in to out and out to in, you have to create actually, my bad, you have to create actually two policies, one in the outward direction, one is in the inward direction. Although that is not the same thing in case of the edge devices. In case of edge devices, the policies that you have, the policies are actually, so edge devices means the data policies. These policies actually they are bidirectional. So in to out and out to in. Let me go and use the arrow and out to in. They are the bidirectional. So the direction for the data policy they are, so data policies are, that means you don't have to create two policies to apply in two direction, bidirectional. And that's why when we are choosing the policy, we are preferring the data policies over the control policy. Means both have their significance, but you don't want to. So for example, service chaining policy. Service chaining means you are redirecting the traffic towards some security device. Why you will create and manage two policies? Why not create one service chaining policy and that will be applicable in out out in, from edge to V smart to VH. So our manageability will be less. So it depends upon what type of policy we have. If it is not required to create two policies in two directions, then we are preferring the data policy on such cases. Okay. All right. So these are the three major differences we have while we are talking about the control policy and the data policy. And these things will come means over the time. Once you start practicing working on that, you will understand the use of CAE, the use means the by default the data policy will be downloaded by the edge devices. Control policy reside at the level of VS Smart. And then the direction is also very interesting thing, that how you're applying the policy at that time, direction will come into the picture. Okay, so knowing these things, now we have to go and understand the construction, the construct of the policy, how this policy buildup is happening. Either it's a data policy or it's a control policy. By the end of day, they are policy. So implicitly, I have policy. Now let's try to understand the policy building block, how the policies are built. So either it's a data policy or it's a control policy, since a construct are same. So suppose this is control policy, should be same only. Or you have the data policy, DP. Their structure will be the same. A structure means that what you need to do while creating such type of policies, you have actually three sections. Either it's a data policy or it's a control policy. Further, it is dividing into three parts. What three part we have? You will understand from this that first of all, we have to think that why we are creating policy, right? Why you want the policy? We want the policy to do some effect, to do some influence to some parties, right? So we have to go and collect the information that which is the interesting traffic to whom we want to write the policy, right? So obviously you want to create policy, but you have to go and you need to define that with this policy, which is the interesting traffic I want to affect. So what does it means? That you have to go and first of all define the interesting parties or the traffic. Traffic means that, okay, you want to create a policy for branch 1, and for that particular branch, for one subnet or for one VPN or for one TLOC or for one application, right? So that means that traffic, interesting traffic, who is the interesting parties that to whom we want to uh, create the policy. And so the traffic, actually the traffic, or actually it is defined here in the SD-WAN as a list. They are the interesting parties to whom we want to create the policy. Actually it's like, okay, so list or the traffic class, right? So what type of classes? You may have VPNs. I will log into the device and I will show you something before going there. Let's go here. So suppose I want to create some policy. Everything we have to do via the GUI. So policy list, and if I type question mark here, you can see that list I have app list, VPN list, and this and that, what list I have. So the interesting parties are these app list, oops, application probe class. When we'll do application aware routing policies, then you will understand this. Color list, community list, IPv6 prefix, data prefix. Now in this list, you will see one interesting thing, that the list we have twice. And it's actually very interesting why we have this list, prefix list, 2 times. So you will see here that you have data prefix list, and then again you will see that you have prefix list and data prefix list, or IPv6 prefix list, IPv6 data prefix list. Why we have this twice? So since we have two different type of policy, we have data policy and control policy. So within data policy, if you want to add some prefix list, you have to go and use this data prefix list. If you are creating control policy, at that time, if you want to have some access list, you have to use this prefix list. That's why we have this segregation. So now the first part of the policy is this, that what is your interesting traffic? Your interesting traffic is application traffic or data or access list or region or site or TLOC, etc. So to whom we are writing the policy, this is our part 1, that first of all you should go and define this number. You have to go and do this thing. This is a step 1, right? So once you have the interesting traffic, then obviously you will go and create the policy. So now what type of policy you have? You have to go and define type of policy. So is this a CP or it's a DP? Right, control policy or data policy. Now, either it's a control policy or it's a data policy. Again you have to go and check the construction of the policy. Construction of policy is something very interesting. We have the construction, the organization of the policy, how it will be. So organization of policy means the policy. So second part is itself is the policy part. policy part that you have to go and create the policy. Whenever I am giving the training, I'm telling that, okay, just remember one keyword called MAD. Then you will understand this. MAD means match and take action. So when you are defining the policy, how you are doing, let's see. So now we can go policy, and then policy, if I type question mark, you can see policy is data policy or it's a control policy. Either it's a data policy or control policy. The construct will be the same. The formation of policy will be same. So suppose if I type control policy ABC and press enter, and if I type question mark sequence, you can see sequence, okay, sequence number 10, and if I type question mark action match action, that's the MAD, match and take action. So okay, I want to match what I want to match. Let's see, match the, okay, TLOC site ID, for example, site ID 300, just to show you. Exit and take action, accept. Then I can go to, this time I can go to sequence number 20 and then match what I, okay, TLOC site ID, for example, this time 400, exit, exit, action. Oops, I should be in the, okay, I'll show you that. We are in the sequence number 20 only, then I can take action, accept. So what I'm telling here is this, that, okay, let's see, show configuration, the policy construct. So policy construct, you will see here, the construction of policy is something that will be MAD in terms of that you have to go and match and take action. So now you will see here that sequence 10, oops, sequence 10 is gone. But anyways, I'll go and put something there, whatever we have created. So you are going in sequence number 10 and you are putting match this TLOC with the site ID, for example, 300. And then you are taking the action, suppose this is 400. What action you are taking? You should have the action statement as well there. Let me see this. Okay, now it is perfect. And I don't need this. Let me remove this. Now this is the perfect example, you'll understand. So now you can see that what we are doing here is this, that we are matching something. So we are going within the policy. So we are in the policy. Once we are in the policy, then define either it's a control policy or data policy. Then go to the sequence. From here, it is very much like Cisco route map. Sequence 10, match what you want to match. These things you want to match, any of these items. So in this case, suppose matching the site ID. You will see some site list, site ID or site list. Then with this match, MAD, match and take action, action accept. Okay, I'm matching the site ID for all the TLOCs and accepting it. Then sequence number 20, match the TLOC for site ID 400. Okay, again matching this. Then here also we are taking action as a accept. So likewise, you can go and create n number of sequence, right? Then we may have, so likewise we have, see, we have sequence number 10, then 20, then 30. Likewise, we may reach to sequence number n. But once you reach all the sequences, then finally you have to come out of the sequence where you have the default action, and for that I have mentioned this as a mad d, like say default. So once match action, match action, match action, then default, default you can go and take this as a reject or accept, up to us. Okay, so this is the part 2 of the policy. The part 1 is interesting traffic. Part 2 is itself what type of policy. It's a data policy, it's a control policy. Once you define that, then you will move to third section where actually you have to go and apply the policy. This is actually very easy and straightforward. Apply policy. But we have to consider something here. While we are applying the policy, we have to do some measures here. So let's see the third number. Third thing we have here is this, that we want to apply this policy. So this apply policy, always you have to go and consider the direction. Apply policy having use case here, that what will be the direction for this apply policy, right? And it's very interesting. If you have the control policy, then when you apply, you will apply this to in out, right? And if you have data policy, so direction is straightforward in the data policies. Then for the data policy, you don't need to worry about the direction. It will be in one direction only. So suppose this is my VSmart and this is my edge device. Suppose this is my VSmart and this is my edge device. The point here is this. One very important point here is this, that we should mark that apply policy 100% of time, all the time, at the rate of site. Whenever you are applying the policy, it is applicable to some site. 100% of time, it will be with respect to the site, site ID, site 300, 400, 500, etc. It is specific to the site. And if it is a data policy, by default, it will be bidirectional. If it is a control policy, then it has the direction in out. Out means from VSmart to edge. So this direction should be corrected. Out means this actually. The policy effect is from VSmart to VEdge. In means the policy direction is from edge device to VSmart. That's the difference we have in the in and out. When we are applying the policy in to out, out to in, this is the difference that we have. Out means the effect of policy will be VSmart towards edge, in means towards VSmart. And if it is a bidirectional, obviously from VSmart to edge, from edge to VSmart. Okay. All right. So actually, it seems like very small, right? But you need to go and watch this recording at least 2 times, at least last 30 minutes that we have recorded, because this is the, this whatever we have discussed now up to this point, this is actually the heart of the policy within Viptela. Obviously, in upcoming days, we'll go and create the policy, apply it, we'll understand more and more. But all the time, they will come and point to this session only. Whatever we have studied today, we have to go and see all these things in the upcoming sessions.